Hey YouTube, JP Dillon. This is going to be part 2 of the Kenwood ka-8150 service. In order to proceed with proper service in the areas that we have to work in, you're obviously going to want your top cover, your bottom cover off, the little shield that goes behind the speaker selector. Now, in order to access what's on the front panel does fold down, but you have to first release the coupler that holds the input selector shaft here. Let's go ahead and rotate that one click. You're going to want to loosen this. Oh yes, and there's also a retainer clip that's behind here, which we can't really see all that well, and it's back in there. That little C-clip there needs to come out. And then once you have it pulled forward enough, you can fold this down. But in fact, we actually might be able to cheat a little bit. Let's see if we can. We're just going to loosen this a lot, and we're going to pull it free. Okay, that should work. And then what you're going to want to do is you're going to want to loosen this screw here. Take it out. And the one on the equal and opposite side here. And then loosen the bottom screws. And what that will allow, or should allow, is for the front panel to pivot forward so that you can access the circuit boards to resolder. And I don't remember if we have to undo screws at the bottom. I don't think we do. So here it is. When you get those loose, this should... no, we're still hanging up on something. Let's see what that is. It wants to pivot, and it's not striking the... It's not striking that. Well, I guess I can take the remaining screws out and just pull it forward. Because I can't see what else it's rolling on. So let's take the other screws out. Okay, so with the other screws out, you can then pull it forward. There's a guide here I forgot about that it rests in so that it will pivot. And it pivots down at about maybe a 50 or 60 degree angle, and you can work on it. And the points of contention on the Kenwood, this series, is the front panel. And I don't know if you can really see that. I think because the flash is on, it's easy to see. But there's a lot of crummy soldering right here around the regulators. There's a couple of bad connections here where all this flux is. It's obviously gotten a little warm. Kenwood's idea of putting the regulators and stuff behind the front panel was stupid because the heat buildup often kills things. So what you have to do, each one of these little circles here is a electrolytic capacitor for the power supply, and I would check those with an ESR meter. Usually it's the smaller value caps that die before the large value caps. And just as an example, let me get my meter here and see if I can do this while holding the camera. This is going to be tricky. Yeah, I don't think it's going to work so well. Anyway, I'm going to set this down momentarily, and we're just going to check all these guys here with an ESR meter, and if they're bad, you're going to want to replace them, which then complicates more things. Because in order to have enough room, some of the smaller ones, if you're good, you can fish it in there with a pair of hemostats. But usually you have to take the front panel off, which is 3 screws on the top and 3 screws on the bottom. Take all your knobs off, take the retaining nuts off so you can pull this entire board assembly back away from this faceplate to change them out. So it's really not a very fun endeavor but on occasion we will find a capacitor that's bad. So I'm going to test these, and hopefully none of them are trash, because if so, then we've got a whole nother fun mess on our hands. Alright, I was going to mount the camera up and show you here. None of the caps were bad, but I will have to do some resoldering here. So let's just take care of that. Alright, so let's get to resoldering this section of the board. Usually this regulator here tends to pop loose, which this one is almost. There's another one directly underneath it. It's your plus and minus 30 volts, I think. I don't remember. It's crucial to the operation of the preamp and phonostage, which are in fact dual-ended. So those regulator diodes get messed up. These dropping resistors are kind of torn loose here. Power resistors, pretty much anywhere you see the board blackened from heat, you should be looking. These couple of resistors here, with all this flux around it, have gotten really hot. And just kind of a general look over. Like I said, this design was a bad idea because the heat buildup kills things. There's this guy down here which looks kind of shady. This one here next to volume control. They've got a little ring around them. You can tell that they're about ready to break loose. That capacitor lead was hanging there. Trying to see if there's anything else that needs immediate attention. Not really. Okay, so this more or less is good to go. I checked all of these things with the ESR meter, and just to show you, they're all in the 100 microfarad to 330 microfarad range. And if we just kind of go over them real quick, they still pretty much all test like they're new as far as ESR is concerned. So I'm not really going to put forward the effort to change them all since they're all still good. Even the smaller value ones down here, they're still okay too. So I'm just going to leave those be. But oftentimes you'll see these section of capacitors here go bad. And like I said, in order to get to that, it's a bit of a hassle because you have to take off the front panel, and then of course you have to take off all the knobs too. You take off the front panel, and then you have to take off all the retaining nuts behind the potentiometers so that you can separate this board from the panel, and then you can change all these capacitors out. So it's kind of a big hassle. So unless you really have to do it, try to avoid doing it. That's just my opinion. So anyway, what we'll do is we'll put this back together and button it back up, and then we'll look towards the protection circuit of the machine, which is also notorious for problems. So let's get to that. Okay, so now what we want to focus on is the protection circuit of the machine, which is comprised of that relay there. You've got your filter capacitor there, your DC detection capacitors here, and then there's also a timing network comprised of these two capacitors here. Now this one comes out within the allotted amount of time, but if you're having a symptom where the protection circuit is disengaging too quickly, like a second after you turn it on, or it's not disengaging at all and you don't have any offset, or if it's dropping out in the middle of music, volume independent, like even if it's a low volume or a high volume, the relay clicks out and you don't have any offset or other problems, look to this section of the machine. This appears to check out okay in the short term, so I'm not really going to mess with anything here. What I am going to do is I am going to pull this relay out, and we are going to burnish it. So let's flip this thing over and desolder the relay and get that out. Alright, so it's kind of a cockamamie angle, but you can see here, this is the bottom. This is our protection relay, and here are the capacitors associated with that. If you're just curious as to what they should read, let's just flip this on here. They're all still very good. And you've got the 2 DC detect back here. Yeah, they're still fine. We're just going to leave that be and just take the relay out. So what I'm going to do is grab my solder wick. And we'll pop this thing out. Some of these you'll see have folded terminals where they've taken this terminal here and they'll fold it over to try to hold it to the board better. Be very careful when you go to pry that up. Apply heat so that you don't rip the foil trace. Almost out. Okay. Now we get one connection here that's still got a little bit of solder on it. Alright, so she's loose, and I can just tilt this up and grab a hold of this and pull it out. So there's our little relay. So we're going to take this apart and we're going to resurface the contacts because I'm pretty sure they're crusty. Alright, so the way that I usually take these apart, you can see that there's a little notch there. And you can get your tiny screwdriver, and what you do first is get it up in there, and then I will pry up so that it pulls the relay down past the little notch as much as possible. And then I'll insert the screwdriver here and pry a little bit more. Sometimes you can twist it in there and get it in there a little farther and push it past the latch. You heard it click there. Repeat for the other side. It's a little bit of a chore to get it apart. And then, as you can see, it separates. Now, take your spring out, don't lose it, and then we'll pull up the contact plate assembly here. And you can see that there's black stuff on there. That's carbon. That's years of turning it off with the volume up or on with the volume up. The arcing causes pitting and it hurts the things. So what we're going to do is take some very fine sandpaper and we're going to resurface the contacts. And I'll show you how to do the ones down in here, because I don't know if you can see that, but they're just kind of equally as cruddy. So let me get the appropriate sandpaper. Alright, so this is 1000 grit. If it's really rough and pitted, you can sometimes use 600, but 1000 to 2000 is better. And we're just going to go over the contacts here until it's nice and clean looking. Do as little of this as possible since you don't want to take off the contact material itself. Just make sure there's none of that black carbonice or pitting left over. You can see there's a little spotting left. Let's just do a little bit more here. That's better. Now to do the inside one, it's actually not as hard as you'd think. You're going to partially reassemble this. It's a good idea to hold your finger here while reinstalling the spring so that if it misses your finger, it doesn't go shooting off into oblivion. This doesn't work quite as well as a hook tool. Or if you're really dexterous, you can grab it with your fingers and do it that way. Make sure that your spring, come on camera, focus. Your spring is in the little notch here, front and back, so that it doesn't fly away on you. Now, you're going to take your rough side of your sandpaper and you're going to insert it between the contacts with the rough side facing towards the side that you want to burnish. We're just going to slide it through here. And then we're going to press on the contact actuator. We're just going to press down on it. You can see it'll hold it there. And then we're just going to burnish it this way. Assuming the relay isn't too badly damaged, you can do this. If it is badly damaged, if it's got big chunks of metal missing or the contacts are deformed looking, just replace it. So it just snaps all back together. And now we can reinstall it back in the machine. And then we'll get to replacing the line cord, which we found bad in the first video. So let's solder this back in. I won't show you that because, well, that's kind of boring and needless. We'll solder this back in, then we'll get to replacing the line cord. One more thing before we go over the replacing the line cord. Do check this side of the board for loose connections too. They tend to happen towards the rear of the board. Like there's a couple here which are a little shoddy. And I was just noticing that as I had gotten the relay installed back in. There's a couple there that are bad. There are a couple on this side which are equally as crummy. Obviously a little bit of heat build up there. You can move your coax out of the way to work on it. So it looks like you are going to have to look at some boring resoldering for a little bit. But just go over this part of the board. Look for anything obvious that could be a problem later on. Trying to see if there's anything more that I missed. Doesn't look like it. And we'll do this one for good measure because it looks like it's starting to crystallize. This one too. Alright, so yeah, check over that board too. See if there's anything that stands out. And then now I guess we can get to replacing the line cord. So I just cut the old one off. There's its little spud hanging out. Now, you can do similar, quit shaking, you can do similar here that you did with the front panel. Release the two screws and pull it forward, and this tilts down to help you with soldering on the cable. But to get it out is pretty straightforward. I'm just going to get a set of vice grips and set them to tug on the strain relief here. Let's see, let's make this sure this is set. Squeeze on the clamper and it should pull right out. And then you can separate the two like this. And then what we'll do is we'll flip this over and pull the back panel down so you can see where it attaches. So with your back panel pulled down, you can see that the cord just comes in and it attaches right here. So that's whoop-de-doo, not a big deal. Somebody originally had this on 220, so the cord that they had with it was just kind of jerry-rigged to put in here. Let's see how easily I can get this out of here without damaging the plastic. These old plastic outlets on the back oftentimes will die, and as a result of that death, they will become dangerous and allow arcing to occur to the chassis. And then I want to talk to you about line cords, because there's all this bullshit on the internet about how you have to have this Mobus power cord or 3-wire grounding and all this stuff that's just snake oil and BS. Now, the reason why people say you put a bigger power cord on it is because it helps the sound. Well, not really. Under high load conditions, it may help with loss. You might lose a couple of volts. I'm just going to cut this because it's being uncooperative. You may lose a couple of volts, but you won't. It's not significant enough to mean anything. And then the 3-wire grounding thing. Don't do that unless you ground everything. If you just ground your amplifier and the rest of your devices are floating, now your amplifier becomes a current path to ground. So if there's any leakage on any of your equipment and you happen to touch your amplifier and something else that's not grounded at the same time, you're going to get the shit shocked out of you. So just don't do that. Now, assuming everything is perfectly working order, you might get a little tingle and not a shock, or, you know, all this stuff comes into mind. But you know what? Just don't do it. If everything's originally designed to float, it's going to float. Let it float. If it's all supposed to be grounded, all ground it. But don't do this haphazard, my amplifier's got a 3-wire ground, it makes it sound better crap, because it's just, no. Just stop. Let's get our cord and put it in. Alright, so in the spirit of vintage, we're keeping our standard 14 gauge, what came with the set type wire. And I'm just going to feed it through here. Already got it stripped back. I'm going to try to partially wrap it around one of the terminals here. And then we're going to dump a bunch of solder on it. And let that liquefy. Now I'm holding the cord with my left hand underneath so that it doesn't fall through the hole long enough to get it attached. And then we'll come over here and we'll do this other one, which isn't going to be as cooperative, of course. And then we're going to solder this guy in. Okie dokie, that's grabbing it. Excellent. So let's put the back panel back up and push in our strain relief. Alright, so we're going to put our strain relief in kind of the same way that we took it out. I'm just going to fit the wire into here. And you want to try to squeeze these together as much as you can to get it to clamper in. It's a little bit of a tight fit now that you've got a cord here in your way. Squeeze it with the vice grips to clamp it, and then see if we can squeeze it in here. There we go. And then if you want, you can spread this out a little bit and get it to lock in place. Give it a good tug, make sure it's not coming out. And that's that. So the cord's in. Last thing we'll do is the setup adjustments. Alright, so after your set's been on a while, at least a good 15 minutes, you should do the setup adjustments on the amplifiers. Now that means that you'll need a multimeter and preferably a set of test leads. I don't like to do this without test leads. If you just try to juggle the probe and adjustment and all that, you'll probably blow it up. You also want a service manual to know what you're adjusting and how. But on this one, the blue potentiometer back here is the offset. That's the offset, and that metal one there and there is the bias. And you want to be really careful about the bias controls, because if you adjust too quickly, or the pot's got a dead spot in it or something like that, you can really kill the amplifier. Because if the bias goes away, or bias pot goes away, it's going to cause the amplifier to go into thermal runaway real quick. Alright, so I'm on the right channel right now, and I'm going to adjust the offset. And right now it's pretty damn good. It's actually about 1.4 millivolts. In fact, if it's under 10 millivolts, I would just leave it alone. Let's see what the left channel looks like here. Left channel is 10 millivolts. Yeah, what the hell, let's see if we can turn it down. See, one way goes negative and one way goes positive. There we go, there's 1 millivolt, that's pretty close. We're going to leave that one be. Now let's adjust the bias. This is the dangerous part. Alright, it's hard to see from this vantage, but the two test points on the 8150, which is a gray face 8100 by the way, you've got test point here and here, and you've got an equal one over here and over here. That's supposed to be no more than 14 millivolts after it's been on a while. And like I said, you really want test clips here insulated so that you don't blow it up. Because all you have to do is touch one of those to another voltage potential or short them together and bye-bye amplifier. So don't do that. We're going to get our test leads on here. And so right now, the thing is under biased. We've got a bias current of 3.1 millivolts, which is too low. So I'm going to take the potentiometer and turn it very slowly. Wow, see how much of a jump that is? Maybe a couple degrees of arc. And we're right there. There's 15, here we go, 14. 14.3. Now don't be surprised if it starts to raise up a little bit, because you've adjusted the bias, and until the thermal compensation kicks in, it's going to rise a little bit. Now you can turn it down and do that a couple more times until things stabilize. It's also very important to watch for what's called thermal creep, where the bias will keep going up in a rapid fashion without ever stabilizing. Then you've got problems. It's starting to stabilize there. Alright. I'm going to have to cut to the next video because I'm running out of space. I'm only allowed 23 minutes recording time, which is, I don't know, whatever, software limitations. So I'm going to really quickly here just turn this back down again, and then we'll start a new video. See how touchy that is? You've got to be really careful with that. Alright, let's adjust the right side. Alright, so now we're going to tweak the right side, as we can see that it's low as well. So really careful, like. See, again, it's like really sensitive. That was maybe a couple of degrees of arc, so don't just go in there ramping it up. You'll just blow it up. Also, if you start to touch the bias pot and it goes crazy, I would consider cleaning that pot before doing any more adjustments. See, this one's really touchy too. Don't really care for these type of potentiometers. The ones that they used for the offset were much more popular, and they're sealed, so you have less problems with oxidation and stuff that this one has. 13.7, 8, 9, 4, 1. See how this one's starting to creep up faster than the other one was? It's stabilizing at least. That's good. Yeah, this is close enough. I could be playing with this all day. So let's hook it up to a load and now see what its performance is like, now that everything on it is fixed. Alright, so here it is, all hooked up to a load. We can see that we have a nice clean sine wave. Balance left and right. The attenuator switch isn't touching anymore. All of this stuff is working pretty good. We're going to do a clip test and see what it puts out. Let's see here. The switch is a little touchy. I sprayed some contact cleaner in there earlier. We'll have to go over that with a little more aggressiveness. Bring it up to the clip point. Back it off a hair. Alright. Yep, that's right at the clip point. And that's 2680. About, I don't know, 75, 78 watts. I don't remember. 26 squared divided by load impedance, 8 ohms. So, do the math. Probably about 75, 80 watts per channel. It's doing okay. This muting switch here, this attenuator switch, is really touchy. The more I use it, the better it's getting. Still kind of touchy. You can see the little static that appears in the right channel. Hose it with some contact cleaner some more, but otherwise, this thing's working good. Let's see if we have a, let's do like 2.83. So we got a real RMS watt, or 2.87, I forget. And then we'll just sweep the frequency up and down. Amplitude's pretty linear. It's not until you get after 25K that it starts to go down. It's about what you want. So it's working good. That's really the aspects of servicing it. I'm going to maybe do a part 3 where I clean up the case and we deal with all of these little crusty things here, these little barnacles. When you live near the coast, you get what's called the beach disease, where the barnacles set in. And you see the surface rust on metal and stuff like that, but we may or may not take care of that. So you may see a third video, you may not, but this has been how to properly service one of these. This is valid for the 8100 as well, so I'll put that in the title just so that people get an idea. So anyway, thanks for watching the video. More stuff to come soon.